police are outside.
Police? I didn't see police.
Well, there's one cop car hanging out with a picture. Oh, man. Door's closed. Let's go home. Are you the reason the cop was outside?
The what?
The cop? You robbed a bank or anything? Drug dogs are here, so now there's some cops that sitting on like this.
I think he's watching the car outside.
Yeah.
I think on that side.
It's weird because there's no one like you can't catch anyone speeding.
On Davenport.
No, he's in the parking lot.
He's facing the source over there.
Yeah. But he's like over there. I don't know.
I think my favorite part of this test, sir, would be the binomial theorem.
Well, good. Because there's a few,
You like binomials?
there's a few questions on that. 4 questions.
How many questions are there?
That's a good question. 1, 2, 3, 4, 5, 6. 8, 10, 11.
Well, okay.
Alright, 12. I have a pretty long word problem on here. Involving encryption.
You're testing our comprehension skills.
That's right.
Figure out the copy.
Gotta make sure you know how to read and stuff.
I didn't know. Expected that from us in 12th grade.
That's been a lot. Handwriting. Well, that's way too much.
God, my freshmen are gonna be sophomores next year. That's horrifying.
Stupid phones.
The problem is having an issue with this car. It continues to lock itself. Like it's unlocked and you have the car running and then all of a sudden it just locks itself.
Oh, sweet.
That's yours.
Money. I love money.
You know what to do? Yeah, I
Not donating.
don't really need it now, but I'll say.
Oh,
Still need it to share right now.
hey,
What you drinking?
Coke. I asked them if they were the reason the cops are outside. Skip check the Rosemore.
The first one.
Yeah, what's that? I asked them if they're the reason the cops are outside because there's a cop car just sitting there. Yeah, what's cop car up there? You didn't know?
Well, we are affiliated with the catch game, so might be that.
Probably.
Massive raid coming.
Massive raid this morning. One of the catch games must be locked up somewhere. I haven't seen it around for a long time.
Got that?
We will confirm before we night that station.
The catch game,
We are we're continuing our
Remember,
I think what's going to happen is,
you have to stick to the story, so you guys have to know it.
I think what's going on is just because so many Texans are pro-Trump, they're going to throw a riot, and they're trying to find whatever cars they can and blow them up. So they saw that there were a lot of cars here, so they stationed a police guy here. I was like, nope, no blowing up cars today.
Mark's right here down Frankfurt.
Yeah, exactly.
Still on our title.
I'm right now.
In that case, go easy, please.
Go easy.
I didn't have that much time to write.
First thing to tell
When he always thinks the opposite.
Exactly.
So he wants it more.
Let's say not exactly.
I put it in all the time, making
Want you to derive. What do you think will be good to derive? The standard model from an SU3 by SU2 by U1 symmetry circuit?
Yeah, that's a good start. That should be like 20 minutes. From first principles, so right to
Right. So you got to go from ordinate transformation. So of course the scalar field is the same in one certain system as another, so B of X mu is equal to B of X nu, so then you take the derivative with respect to X mu. That gives you a partial derivative of X nu with respect to X mu times the derivative of B with respect to X nu.
It's trivial.
Simple stuff. Now you've got your covariant vector field transformation down to the scalar field. And then you can figure out the covariant derivative from that, of course. Christoffel symbols. Pretty simple, straightforward to drive.
I could walk in a park, sir. That's only gonna take you 2 minutes.
Yeah, 2 minutes max.
Come on, guys. The Christoffel symbols,
You should always allow fun, though.
they're given by this. It's quite easy.
Really?
I always forget the order that I have to go.
Really did either.
I think so.
Have I taught you guys nothing about this stuff? My goodness. See, Christoffel
Well,
symbols are quite easy.
you can't expect everyone to pay attention all the time in class, right?
Well, I mean, this should be done in your sleep. You should have
Everyone does this algebra.
quite simple.
Except for the front.
Metric tensor, derivative with respect to the metric tensor. This is how you get your geodesic equations. Alright. D tau squared plus an alpha beta.
That's not this.
Has anyone passed out there?
I don't have to mark that for it.
So that becomes the basis of most physics, actually.
So why don't you teach this to us?
They should. If I was in charge of education in this nation, you would know. Well, you wouldn't know how to do this, but you would know how algebra would be taught in an abstract way using
Group theory. Once you know how to
We
multiply.
would have done physics with calculus, though.
yes, absolutely. Yeah, I mean, group theory is just ways to multiply. So, for instance, remember what I told you about I, right? There's a finite group formed by I.
Yes.
You can either have -1, 1, I, or
Negative I.
and you can actually apply that to all of numbers in number theory.
I was trying to explain it to somebody, and it's like,
Tomorrow is 0 hour or
it's 0 hour thing, 0 hour tomorrow.
But you guys should be able to finish it today. Which if you finish it today, then we can tomorrow.
I was trying to explain to somebody the I set, and I said, so what's the meaning of I to the 4,000? What is that? They didn't get it.
Alright, so 4,000 is 1. 4,000 is supposed to be
And he used the moment for it.
Yeah, I is interesting because
It's a rotation. So what you're doing here is you have I, so you've got your imaginaries and then your reals. And so if you are at 0, then you're not doing anything. If you multiply by I, that's the equivalent of rotating by 90 degrees. Multiply by I again, you get -1, so the negative reals. Multiply by I again, you get the negative imaginaries. Multiply by I,
It's 1.
get back. So there's only there's only a combination of 4 multiple ways to do this. So multiplication by I is a rotation by 90 degrees. You're taking the reals, rotating by 90. So that's why I to the 4th. If you're multiplying by 90 every time, 4 times 90 is 360. Get back at 1. So pretty straightforward.
But if I was in charge of education for the nation, I would have everyone doing calculus by probably,
what, 3rd grade?
no, probably 8th.
And then post 8.
Post 8th would be going into the more, abstract, like number theory. Actually, I would start with number theory.
Well, Calc 1, Calc 2,
Yeah.
Calc
Yeah, there's a lot of calculus.
1, GQ.
Yeah. Yep. Yeah, it's weird.
The other terrifying keyword charged.
God, it would be so good, though. So good. If we're going to equate education with merit, tutors shouldn't be allowed. That will be another thing that I would
calculus. That's what med schools are learning the hard way. Is that they're admitting all of these people who, you know, their entire lives, they've got amazing grades and amazing test scores, but their entire life they've had tutors, tutor them on the LSAT, or not the LSAT, GMAT, tutor them on the SAT and the ACT, and then they can tutor them in their class, so they've never had to really think about anything for more than 10 minutes. And they're realizing, that's actually not too good when you're under pressure. So,
Really? Couldn't have told.
who would have thought? So,
Prices just keep coming.
yeah. So things are changing, but yeah, I think with math, you learn when you're in really first grade, third grade, you're learning a lot, and then for whatever reason, you just stop. It's like, okay, now you know how to multiply, so now we're going to multiply two-digit numbers by 2. Spend an entire year on it's stupid. If you know how to multiply, you, in principle, know how to do all of this stuff. If you know algebra, you know how to do calculus. It all builds on itself, so it should move fast. Learning stuff at an abstract level, you're more geared towards doing that when you're younger. I mean, think about all you learn with language. So,
A couple of days ago, sir, my youngest brother was going around the house and he was counting. And when he got to 29, he knew what 2010.
yeah.
So I was thinking about this, and then
It makes sense, like that.
right, so then it makes sense. I was thinking about it, and then last night I was thinking that's how we prove the number of infinite. Because if we go 2010, 2011, 2012, 2013, 2014, 2015, 2016, 2017, 2018, 2019, and then 2020. Well, if the world hasn't ended by 2020, then we just never going with that thing.
That's true. Well, remember, that was one of the proofs I gave to all the classes here initially was, prove that there's no largest number. Well, assume there's a largest number, add 1 to it. Well, that number is larger than n,
Yeah.
so therefore we derive a contradiction. So, also another, speaking of the binomial theorem, a good proof. So prove 4n minus 1 is 3 divides 4n minus 1 for all n. In the naturals. And so what you can do is actually use binomial theorem for this. So 1 plus 3 is equal to 4 to the n, right?
Right.
But then this is the sum of mu equals 0
Up to n.
up to n, whatever n is.
And choose
And then you just have 3 mu, right? Because 1
As long as it's always me.
So then this becomes 4 to the n is equal to, well, mu equals 0, so that's just n mu plus n1, 3, plus n2, 3 squared, plus all the way to nn, 3 to the n, right? Well, this is 1. So now you have 4 to the n minus 1 is equal to n1 times 3 plus n2 times 3 squared plus n, 3 to the n. Well, notice I can factor a 3 out of here. Because all of these, so that means this has to be divisible by 3.
Well, simple way to do it.
So I was working on some stuff at home yesterday, and I was using binomial theorem. I was like, that would be a good exercise to show how you can use number theory in a specific way. Yep, math and stuff.
The thing that makes the world turn around.
Literally. You have your USB, I'm guessing. I'm going to make the Algebra 2 test while I'm being pre-cal about this.
Write the answers would be called that? That would be my favorite about